All right, but we have to do this because it is a parabola, and it does have, because it is a parabola, and it does have a secant. Hold on, let me focus. I'm in calculus mode now. I'm meeting out of calculus mode, or else we'll get in trouble. I'll get in trouble. Switch. HonorsPrecalc. Parabolas. Geometry. Focus. Literally. Parabola has a focus. Parabola has a focus, and that's why we don't need calculus.
Good. Like air server.
I was just bringing that up. Okay, because a parabola has a focus, we don't need calculus. Question, yesterday, I think we were trying to find the focus, and we had to, didn't we have to change things a little bit, how it was written? We had like a y, 1, and then a y. And then, yeah, we started this, right? We just didn't get to finish it. And then 4p had to equal 1, because that's in the 4p spot, right? And then p is going to equal 1/4. And it's a positive, because it's concave left, and all that makes sense. So we know our focus is at, see, that'd be like a half, that'd be like a fourth. Is that a fourth-ish? That's where the light bulb should be in the parabolic reflector to make it go straight out. Anyway, reminding you of the application from yesterday. Okay, we have the point 0, 1/4. We have the point 1, 1. And what do we know about the distance from the focus to a point and the focus to the other point? You can see I didn't draw it so hard. Don't trust the picture. Hey, geometry all over again. These are equidistant, even if the picture doesn't look like it. These are congruent. So, which one can I find because I know the 2 points?
The distance between 0 and the focus and
Yep.
the tangent touch.
So let's find D. D is equal to distance formula times square root. Wait, it might catch up. D equals, come on, square root. Okay. Try to be nice to it and not really do much. 1 minus 0, you guys will be fans, right? Plus 1 minus 1/4. X2 minus x1 squared plus y2 minus y1 squared. How are we looking? Okay. So I have 1 squared is 1. I have 3/4 squared is 9/16. Is that too fast? 1 squared is 1. 1 minus 1/4. Something cut in fourths, take away 1 3/4 squared, it's 9/16. Ew, gross. How are you supposed to square? Hey, common denominators. 16 over 16 plus 9 over 16 is 25 over 16. That just got nice. That's 5 over 4. So, if D is 5 over 4, and D is congruent to the distance between the focus and this second point on the tangent line, the focus lets us get another point on the tangent line. As you go down, how far? So D is 5/4. So this distance has to be 5/4, but I'm going down that amount, right? Then what's my new point going to be that I can use? 1/4 minus 5/4 is negative 4/4, which is 0, negative 1. With the focus of a parabola, we can find a second point on the tangent. It's pretty crazy in the sense of that's what calculus does for every other function, every other curve besides a parabola. Well, and besides a line. Because a line we can find the slope and everything. So now what can we do to make the equation of our tangent line? Yep, tangent line time. Point slope. Y minus y1 equals m times x minus x1. Does it matter which point we choose as long as it's one of the ones on the tangent line? Nope, we can choose either one. Which one looks nicer to plug in? You want 1, 1? Or do you want 0, negative 1? Okay, so y minus 1 equals, how are we going to find m though? Exactly, we have these 2 points. Let's take them off to the side and say, hey, we can do the impossible. Find the slope of the tangent line, 0 over 0 by doing y2 minus y1 all over x2 minus x1. Am I going the right way? Negative 1 minus 1. Yeah. I end up with negative 2 over negative 1, which is positive 2. Does that make sense in the sense of being positive? Yeah. So let's plug them in and say, the cool thing is, once you get to calculus, we say stick it to the man and say, haha, we have a line. We're not going to make it wrong by simplifying. But there are those rare choices, or rare times, like in multiple choice problems, where it's good to reduce. So we don't want to totally forget that skill. We end up with y is equal to 2x minus. There he is. In calculus, this cool thing up here called slope of a tangent line, we could find this thing called a derivative. And the derivative of x squared is 2x to the 1, which is kind of crazy. And then we could actually plug in the point of tangency, which is at 1, 1. And we'd say 2 times 1 is 2. But that takes a lot of calculus you guys don't know. So I'm going to erase that really quickly and say, hey, it's coming one of these days. For most of you. All right, kiddos, put that 10-2 then. Have homework ready for Monday. 10-3, let's go. 10-3, let's go. This is what we're supposed to be doing today. Tangent line because of computer and because of me having fun with calculus. One a little too crazy. But you could tell calculus kids, calculus kids that you guys did a tangent line today. They'll be very proud. Or they might wince. Hopefully they'll be like, I know what that is. Maybe not much else. Just kidding. They know a lot. They have their Saturday finals tomorrow.
Oh.
What are they doing for the rest of the
Oh, we still have a month till the actual AP, but it was the only weekend I could give them a mock AP. Where I had time to grade it and give it to them, but no have to do anything.
Yeah, you know.
We have a lot.
What time do they have to get here?
I don't have like food and coffee and breakfast steaks and all sorts of stuff, so they're gonna get here at like 7:45. To eat maybe 7:30.
How long are you doing?
4 hours. Like it's section. It's not all.
I tried to get out of it.
They'll be tired of them. What am I doing? I'm getting magnets. They're up there. I'm getting my string. That's what I'm doing. Ellipses. You guys have seen these before, right?
Probably.
Uh-oh.
Mm-hmm.
No.
Oh, it's a dot, dot, dot. Oh. Actually, I don't remember. Oh,
It's like stuck a little bit, so that's why yeah, there we go.
For a circle. For a circle, you guys saw me yesterday start at one point and have the marker extend, right? And like a protractor, nope, compass, just kidding. Like a compass, you can twirl it and make a circle, right? Doesn't work for a parabola because a parabola distances are always changing, but especially with the focus and the directrix, those are equidistant, etc., etc. How does an ellipse come about? An ellipse has foci as well, but not just one. An ellipse has foci also, but not just one. It's going to be a little rough because the magnets don't work. There we go.
Wow.
She went.
Is that a circle? No.
No?
It's not a circle.
It's in
Whoa.
ellipses?
It's a little bit squished.
Oh,
It's a
no.
little bit squished. It looks like a circle, but it's not. How do I know? Because it was drawn from two foci. But the foci are pretty close to the center, so it's pretty circular. What's going to happen if I move the foci to be out quite a bit more?
Distortion.
Distortion for sure. But what kind of distortion?
Major. Horizontal.
That looks crooked.
It looks like I'm really like demented snowman.
The next day before Christmas.
Yeah.
Jack.
I was like 17.
Jack Skellington. That's gonna look like if you drew one, it would look like an astronaut. Oh my goodness, yes!
It looks like eyelids. Dude, it looks like
Oh, yeah, it does.
It looks like that.
Question, what happened to him?
Monsters Inc.
Squished
He
more.
got
Yeah.
squished more! Now, wait. Do you guys notice the foci?
Yes.
The foci are all along, approximately all along what? One line. The horizontal, true?
Yeah.
Okay. So if the foci are on the horizontal, then question, kiddos, how is it getting squished? What's going to be the, ooh, ready? Turn.
It's a stretch.
If I think about this circle, normally just has, a circle has one radius, right? It's the same all the way around. But when I'm talking about an ellipse, it's going to have one distance going up, and it's going to have a very different distance going out. Which one's going to be the major one? Which one's going to be the minor one if the foci are on the horizontal? The major is the horizontal, because it's bigger, and the minor is going to be the vertical, because it's smaller, aka it's getting squished down, right? Okay. Now, technically for this one, well, let's just keep it. What if I was to make my foci, this is for the blue, right? We had the foci way out here. So the farther the foci are from the center, the more distorted the ellipse is. What if I was to go vertical on the foci? Any ideas? Does that kind of make sense? So if I was to do the vertical, I know, judgment. Okay, so if I was to go pizza bay, right? Can you guys tell from how far this is? Is this going to be pretty distorted? Yeah. And is the major axis this time going to be horizontal or vertical? It fudged. I know. Who fudged? Oh, this guy fudged. He's messing this up. No, he's fudging.
Well, it's forming something pretty cool though.
Just gonna fill it in. Perhaps judging.
Yes, a globe.
Okay. Where's the major? And where's the minor? That makes sense? So, the ellipse. How's it come around? How's it come about? You guys see the little foci? So how many focuses, foci, does an ellipse need to have?
Can I have no wait. Oh, I can't have one.
2. It still has a center, just like a circle, but unlike a circle where the foci are theoretically or actually on top of each other, on the center, all of them converge. Ooh, still using that term. In the center, that's a circle. As soon as the foci start to remove from the center horizontally, you're going to get squished down or pulled down. The major axis horizontal, minor axis vertical. When the foci start to split apart up, it's going to get more guess you could say stretch. With the major axis vertical, minor axis horizontal. Now guys, the visualization is just what I did up on the board. Before we get too much farther, let me go ahead and wherever my iPad is chilling. Oh, I left it over there. What's the standard form of the circle equation? What if it was a circle? What would that equation look like? No. The equation. The equation. X minus
squared
plus
1 minus k squared equals the radius squared.
Let's think of it this way. If I was to divide everything by the radius squared, question. I would have this side equal to 1. Do you see how the x and y both kind of, if you think about the 1 over r squared as being like a dilation, kind of? This is being multiplied on the outside, right? Wouldn't they both be changing by the exact same amount for a circle? 1 over r squared is the dilation for the x, 1 over r squared is the dilation for the y, in a sense, thinking about the multiplication on the outside. So what do you think is going to happen with an ellipse, how the horizontal is different than the vertical? Those are no longer going to be the same. Okay. Instead of having r squared and r squared, we're going to have a squared and b squared. Let me zoom in on the top one just so we can get a really good first picture. Instead of being over r squared and over r squared, this looks a lot like a circle, but I can't multiply one constant to the other side to get rid of the fractions and to get an r squared on the other side. I can't do it, not for an ellipse, because x and y are being distorted, being stretched, being dilated differently, as you guys can tell from what's on the board. So we're going to have different constants that we can't move to the other side, so it's not going to look quite as pretty as just the equation of a normal circle. If they were the same, it would be a circle, but if they're different, it's an ellipse. We just all need to admit that we're not as perfect as Mrs. Leon and just kind of do it in little baby steps. Because if you do it in baby steps, you know what I mean? That's how most artists do it. They don't draw it one time and then they have it right. They kind of just, right?
That's how it is.
You sketch it. Especially with like pencil drawings.
Yeah.
You just get a general shape that's right. And you're like, oh yay, look, that looks good.
Wow.
But if I tried to connect it just once, guys, my ones who are artists in training, yay! That doesn't work so good, right? Yay! That doesn't work so good either. When you start to make it nice.
I took art class this summer, and I still don't know how to draw.
Alright, party poopers.
Pass with a 93.
Make sure we're multitasking.
We are.
Alright.
She drawn.
So we have the major, right? It's horizontal. You can do it on the left or the right. It's just a distance. It's the same either way.
Wait, they look the same. The formula.
No, the A and the B are switched.
The A and the B are switched.
Yeah.
The major axis is always going to be seen with the length of A, whereas the minor axis is going to be seen with the length of B. So we could say A is always going to be greater than B. So sometimes the bigger number will be under the X. Sometimes the bigger number will be under the Y. Does that make sense? Whereas down here in this one, if we were to go the other way, the major is going to be vertical. I wanted the highlighter instead. Whereas the minor is going to be horizontal. Does that make sense? Why A is under different ones for different equations?
Oh, I see.
Nicole, you got it all written down, I think?
Yeah.
Are they distracting you too much?
No, kind of. Really?
Oh.
It's me, it's not them.
Okay.
Oh,
We gotta move
it's not you,
It's
it's me.
Friday, so.
Alright, careful though, this is our trial.
So are you guys free?
Don't worry, Monday's the actual. I'm not getting anybody in trouble today. I'm just giving you a quick little
She good.
Alright, we got it?
Yes.
So, kiddos, one quick thing I need you to see in context of the rest of the chapter. Ready?
Yes.
Circles have a square and a square and a plus. Circles and ellipses have a squared and a squared and a plus. Circles and ellipses have a squared and a squared and a plus. If the orange is too bright, let's try blue. A squared and a squared and a plus. Whichever way it's oriented, a squared and a squared and a plus. Hyperbolas have a squared and a squared and a minus. Parabolas have only one squared. Lines have no squares. Okay, comic sections in a nutshell. Ready for me to keep going? Oh, my perfectionists that talk a lot. Some of you are done. Maybe zoom in.
What is this?
It's not even
a
it's not even a circle.
It's a circle.
Just wait until we get to the fun three-dimensional stuff.
Oh.
Bruh.
Okay,
Where's my foci?
roughly. Wait, where are the foci? Can we pause real quick? We're going to see them in the future, but can we at least say approximately where we know them to be? Guys, for the top one, the foci are going to be where? On the horizontal or the vertical? Horizontal, because it's stretched that way, right? And aren't they going to be at least somewhat kind of removed? Right? They have to be somewhat kind of removed. That's pretty elliptical. Okay. On the vertical, still kind of spread out. Okay, just making sure that you guys know. Let's keep going. Foci, let's talk some more about them. Now, if you want to try and fit it in your old picture, you can. I'm just going to add some stuff about the foci specifically. If you want to try and get them in the old, two, a focus on each side of the center, there you go. Otherwise known as foci plural. A focus on either side of the center, otherwise known as foci plural. Can be found by, wait a minute, some random C is the distance. If you guys want to put this in your other sketch because you made it all nice and pretty, that's totally fine. Long story short, C is going to be the distance away from the center to the focus. So if we have the center, which we do, of H, don't know what that was, right? If I have HK as my center, then I'm going to have H plus C for my ones that like formulas, my H plus C to be on the right, and my H minus C to be on the left. I better stop writing and see if it'll catch up. I'm pretty sure it's just a start time for you to finish. We might be able to start. Oh, no, 10-3, I think we have a lot of shifts to get to. Did you guys do the H plus CK and the H minus CK?
Yeah.
The one on the right. Start with H, add C. So the focus on the right, make it the point H plus C, comma, K. Ooh, we're learning verbally. Audibly something. Auditorily? Wait, focus on the right. Write the ordered pair as H plus C, comma, K. And on the left, you need to subtract C. So H minus C, comma, K. Can you guys figure out how to make the foci on the vertically oriented ones? It's not the H that's changing. It's the K that's changing. Aha! Woo. You can see the H minus C. again, we're gonna have C up, we're gonna have C down. It's still C, it's still related by C. But now my points are gonna change just a little bit because you guys figure out what's gonna be new, what's gonna be different. The middle is still. What's up here? Exactly. H stays the same, okay? Add C. Down here, H stays the same, but okay, minus C. Does that make sense? You guys all tuning out and just saying yes to the agreement?
You got this. We got this.
What'd you say?
So wait a minute, what are we gonna see tomorrow?
Examples.
That's fun. Aw, you don't wanna come tomorrow during the AP test?
Oh. No, I have the AP test.
Now, hold on, wait. We have example, and then, eccentricity and done. So we're close to being done. Example, eccentricity and done. And then,
She looked nice.
that looks fun.
How many C's?
Guys, pause real quick. I still have 35 seconds. Do you see that hyperbolas have a C also?
Yeah.
Yeah? But it's A squared plus B squared. Hold on, go back. Didn't ellipses have a C? Should some of you start making some equation cards?
Yeah.
And one. I think we're just doing 1 through 4, and then we're doing like a random supplemental one that I jotted off. So bye guys. Bye guys. Happy weekend.
Happy Eris Day.
We're not letting go.
Happy Eris.
Alright.